Hi, this is Nick Barber. We're here at the Edison Exploratorium in Schenectady, New York. We're with a special guest, Harold Gauper. Harold is an electrical engineer who has a fantastic and exciting background that he's going to tell us about today. And we want to thank you very much, Harold, for being with us today and talking to us.
It's fun to be here.
Welcome. Harold, you are an engineer. You worked for General Electric Company, like many people did in Schenectady County. And you had a long career with GE. How many years did you work for them?
42 and a half years.
42 and a half years. And what type of work did you do for GE?
I spent about 40 years of that doing research and development work here in Schenectady at General Engineering Laboratory, and which became corporate R&D.
Mm-hmm. And did you have specialties that you worked on, specialty projects? Interference, frequency, and products. Someone told me about that. What does that mean?
After being here in a couple of years on GEL, they needed or wanted someone to work on electromagnetic or electrical interference, and I accepted the assignment and specialized in that for about 37, 38 years.
Really? You must have learned a lot in 37 years studying that particular discipline.
Well, we learned lots of things about lots of product developments that General Electric was involved in.
Mm-hmm. Now, when you say interference frequency, for the people who are watching are not technically oriented, what do you mean? Interference with radios and television, electrical appliances?
We were worried with things like the interference to radios caused by such things as the first lamp dimmers, or when an automobile used to go by the house, we used to hear radio interference in the cars, mm-hmm. or see television interference in the early television. And that's the kind of things that General Electric then could not tolerate, because General Electric manufactured products which made interference, and they manufactured products which received it. Therefore, we didn't want to have either one of them.
Mm-hmm. How were those problems solved? I mean, for a layman, in layman's terms anyway, how did you study that and eventually resolve those issues?
Interesting. We developed methods of measurement first, of course, and then devised techniques to reduce the disturbances that occurred on the power system due to the added products that were there. Mm-hmm. Then it basically talked to the people who were designing the radios and television sets to encourage them to design them to be less susceptible to the radio noise that appeared at their mm-hmm. doors. So
you did solve the problem eventually.
Well, apparently we have interference-free television, mm-hmm. and the telephones work fine, and mm-hmm. radio works good these days.
Did you anticipate this problem as an engineer when these electrical products or devices were manufactured and produced? Did you have an idea that there may be a problem before it actually occurred, or as they were being developed?
As we developed special products, we could look at the electrical characteristic, what's going on, and predict that there was going to be mm-hmm. some kind of an anticipated problem with mm-hmm. a function.
What were the heaviest interference devices? What were the more typical susceptible devices that had electrical interference?
Early on were the radios. As we developed new electronic devices, of course, we used to have computers were, of course, electronic and susceptible to electrical interference. We had mm-hmm. computer interference problems.
Yes.
And in fact, it's interesting that the computers themselves in the early days generated RF energy, which interfered with radios.
Mm-hmm. RF energy meaning radio frequency?
Radio frequencies.
Yes.
Generated, just like broadcast, except they weren't intentionally generated. They interfered with radios.
Yes. Well, that's pretty interesting. You worked with other devices too, inverters and fluorescent lighting, and
each one of these products has some characteristics using electrical energy, which doesn't use it in a nice clean sine wave function, but rather uses it in a step function, or which generates electrical characteristics which are interfering in nature.
Mm-hmm, mm-hmm. What about dimmer switches? I think we talked about dimmer switches before, or rheostats. Did you have experience with that or work in those devices too?
Well, one of the early electrical semiconductor products, of course, was the SER, which was a device for switching power like the power from the power line. And one of the first applications that Johnny Hardin and our friends worked on was a lamp dimmer, which basically turned the voltage off so the light would not be as bright, so we dimmed the lamp. And in doing that, you did it with a very sharp time function. And one of the things that does is causes harmonics, which then cause electrical interference to radios and other things.
Well, you mentioned John Hardin, and John is a founder of the Edison Exploratorium here in Schenectady, New York. So John was a fellow engineer.
John was a fellow engineer, worked down
Still
the
around
hall,
today.
worked down the hall from me.
Worked down the hall?
Building 37.
Oh, that's wonderful. And you still communicate with him to this day?
Still talk to John quite frequently.
And Harold, you don't live in Schenectady anymore, but you formerly lived in Schenectady. Where do you live now?
I now live in Ormond Beach, Florida, which is just half a mile north of Daytona Beach.
And you were kind enough to meet with us here today in Schenectady, New York, to have this visit and this interview. We appreciate it. And you have some family here in Schenectady County yet?
My daughter still resides in Schenectady.
Oh, that's wonderful. We're so glad that you're here. You talked to me earlier in our sort of pre-meeting about the FCC and liaison relationships. Were you sort of a communicator or a representative with the federal government or with the government for GE on issues such as interference and distortion or those types of issues?
Well, the Federal Communications Commission, of course, has regulated and does regulate the reception of radios and television. Now, as a result of that, the electrical industry manufactures some products which causes electrical interference. So there is a problem that the FCC used to be very concerned about because it was a prevalent problem. And as a result of that, there are a number of devices which the Commission regulates, which the General Electric manufacturers, like microwave ovens and others, which they write regulations on. The General Electric company gave them technical inputs so that the regulations would achieve the objectives of the Commission and not be too burdensome on the manufacturer.
So the company collaborated with the FCC to determine guidelines and safe levels and certain specs and requirements for public consumption of these products? Is that what you're saying? Something like that?
I would rephrase it a little bit differently. The Commission proposed regulations and we suggested modifications therein.
Okay, all right.
To control the problem so there would be no problem.
I see. Harold, you work with some very interesting people over the years, very talented people, co-workers. There was a fellow named Hal Chestnut, Harold Chestnut. Same name as you, Harold. Yeah. What was your relationship with Hal Chestnut? Who was he?
Hal was a development engineer in General Engineering Lab and Corporate R&D, and he was one of the early men who recognized the needs for system engineering and building electrical systems of all kinds. That there were more than just a simple problem, it was a big problem, whatever we were doing. And as a result of that, he probably published one of the early books on system engineering, which he authored. And because of my specialty of electrical interference being part of system engineering problems, I authored one chapter in his book.
Oh, wonderful.
And he was an innovative co-worker, as most of my friends were.
Now, you graduated from University of Wisconsin. Is that true?
That's true.
And Hal Chestnut did too?
Not to my knowledge.
No? Well, there were a number of notable engineers that graduated from that institution.
Yes, Guy Suits and some other.
Guy Suits was one of our wizards of Schenectady. You've met and had experiences with other famous people in the technical world. Dr. Alexanderson. Dr. Alexanderson had an office nearby you. Could you tell us a little bit about things that you've seen? I know you didn't work right next to him, but you saw him.
During World War II, we had an office down in the first floor building 37, right next door to where Dr. Alexander had his rotating machines that he experimented with. And we, fortunately, they didn't spin very much while we were there, so we weren't interfered with.
Being in your business of electrical interference, that could have created some issues. Now, he was a pioneer in television development, wasn't he? For those that don't
Did-
know, Dr. Ernest Alexander?
Some of the early work, first color television probably,
Uh-huh.
a system which was replaced with electronic technology, but it was a system.
Yeah. And you also worked on the Manhattan Project in those days of the war, along with some others?
Yes,
That must have been interesting work.
Yes, we were building equipment that went down to Oak Ridge in the mass separation process.
What is EMI? There's an EMI Society, you said. What?
Electromagnetic interference. However, the society of the IEEE is the Electromagnetic Compatibility Society, which deals with the technology of controlling electrical interference, both the source and the receivers of it, so that you and I can talk over the telephone without interference. We can see pictures on a television set without being disturbed by other things.
Yes. So the society is a professional society. You meet annually. Are there conferences? Do engineers exchange ideas and network and talk about these issues?
There's an annual conference around the United States. In fact, I just noted in my email this morning that the first non-U.S. president has been elected, and I'm not even sure what country it's from. I just noted that the IEEE has gone international.
So it's an international organization
now,
now, or a society. Well, that's terrific. Technology's really grown at a rapid pace. You must have seen in your lifetime so many amazing discoveries and changes. We talked about early computers and about hybrid cars. You drive a hybrid car. You don't have to mention the make, but you drive a hybrid car yourself?
I now drive a hybrid car.
Yeah.
And, I enjoy doing it because I remember about 25, 30 years ago, my friends in corporate R&D were built also one of the early hybrid cars, on experimental, of course, at that time.
So you remember those experiments?
I remember those well, yeah.
And you told me about some of the other, I don't know if they're inventions, but solutions, like the first magnetic mine detectors. What was that about?
Well, General Engineering Laboratory had some of the early magnetic field workers who designed and built magnetic field detectors, which were used in World War II to detect the magnetics, and also devised methods to make the ships non-susceptible to magnetic mines.
Was this just ocean or land also, or mostly in the sea and the ocean?
This was the ocean. This was a Navy project, of course.
Yeah. You wrote a technical position paper, I think you had mentioned, with a fellow named Bill Cruzi. Who was Bill Cruzi? To your recollection, anyway. Someone told us about him. That he has a famous relative, or he was a relative of Edison. He may have been Edison's grandson.
No, he was. I think Bill's forefather was one of Edison's early men who came up here to manage the plant that Edison started in Schenectady.
All right. Well, that may be the case.
Bill Cruzi, of course, was one of my co-workers. He worked in Fairfield for the vice president of engineering, and he was the man. And he and I wrote the position papers for General Electric Company before they went to the Federal Communications Commission.
So did you write many position papers for the company and had a lot of relationship with the FCC and the government as far as...
For 15 or 20 years, yes.
Yeah. What were some of your most pleasant memories of your work over the years? What were some of the best experiences that you had, things that you enjoyed in your work? Was there any particular project that you really got excited about? I'm sure everything was interesting. I mean, it must have been an amazing time during your working years to see all of these developments and work with all these talented people. But what was one of your favorite projects?
Oh, that's a tough question.
Okay, so then maybe you liked them all.
As I recall, during my whole career, we enjoyed, most of us enjoyed getting up, going to work every morning, and we enjoyed the work we were doing. We had, there were ups and downs, of course, but we had mutual achievements and of the whole place.
Well, I think that's fair enough. So you had 42 years at GE, right?
Yeah, 42.
Yeah. And now the R&D lab started in what year? The actual physical plant out there in Niskayuna? Because you said you were at the main, well, maybe you don't know the year, but you were at the main plant
Well,
at the cusp of the R&D development.
I started in General Engineering Laboratory when I moved to Schenectady in 1944. As the changing needs of General Electric Company came about, the corporate research and development was formed from General Engineering Laboratory and the research laboratory. And I don't remember the year, frankly, about 1969 or 70.
Late 60s or so, yeah. Well, as you see technology taking off by leaps and bounds, what do you predict for the future here? Where are we going with these achievements? It happens like computers. You talked about an early computer we talked about earlier that was 1 megabyte, was it? What was it?
Remember what they...
Tell us about that computer and the cost of it at that time. The cost of the technology.
So we, of course, measure the storage elements for computers in megabytes or gigabytes, gigabyte being 1,000 megabytes. And in somewhere about 35 years ago, we had in our lab a 1 megabyte storage, which cost about $500,000.
$500,000 for 1 megabyte
now
of storage.
I can buy 10,000 times that for about $10.
That is amazing.
It is truly amazing.
That is truly amazing.
Right.
So if you've seen that in your lifetime, could we imagine what's going to happen in generations to come? I mean, it's almost unimaginable.
Well, the communication age, of course, is moving so fast, it's hard to deter what is going to happen in that area.
Harold, tell us about the work area. It was referred to by someone as an RF shielded room. What does that mean? What's an RF shielded room?
Well, in order to make our measurements and evaluation of products which radiated or emitted interference, we had to have a shielded room which isolated us from the rest of the world.
Really?
And so that was basically a solid steel or copper, depending on the facility, room. We had a couple of rooms. One was about 10 by 15 by 8 feet high, in which we sealed up the door, and it was kept the electrical world outside of us, and we were inside of it. And we could measure such things as the electrical noise coming out of mixers and blenders and computers, and we could also apply RF energy to some of the computer things and find out what happened if we injected high power RF on things to make sure it wasn't caused to be disturbed by that field. And we had many things like a General Electric core engine. We had the jet core of a General Electric jet engine in the laboratory. I recall doing some measurements on the control system for that.
How big was that core of a jet engine?
Well,
what did it look like?
The core was about 10 feet by long by about 2 feet, 3 feet, 3.5 or 4 feet in diameter.
Yeah.
With some electronic pieces on it, but
Yeah.
the core was there.
Yeah.
And we also did some very small things like the small computer for the missile guidance system on the Polaris missile. We were involved in a number of projects like that. We did some initial work for the guidance system for the Atlas nose cone, the control system for that. So we were involved in all sorts of electrical problems that were products and projects that were being developed. General Electric was involved in and started up on.
Yes.
And because of my unique position in the research and the development in the General Engineering Laboratory, we had a chance to contribute to many of these products, and engineers around me recognized the need for system engineering aspects, which we then contributed to.
And you worked with some wonderful people, as we mentioned before. There was a fellow named Bernie Bedford.
Yeah.
Who was Bernie Bedford?
Bernie Bedford was an engineer, a long-time member of the General Engineering Laboratory who worked on heavy power development, magnetic amplifiers, and that kind of device. He was a unique guy, had some inventions that he proposed on power from waves and other things. So it was a far-thinking man. We had, it's another recent retired deceased man, Leeanne Goldberg, who was a long time involved in the application of solid state power management, switchgear and things, from using the newer technology of solid state to
Yes.
for switchgear.
You mentioned Mr. Goldberg to me earlier, and he recently passed away at
102.
102. God bless him. Yeah, that's wonderful. When you went to work, how many people did you typically work with? You were in this shielded room, but what was your office environment like? What was the plant like in those days during your working years? Did you work with a lot of people? Did you prefer to work isolated, like are you one of those people that likes to work alone, or did you like to collaborate with other people? What was it like as far as your coworkers?
There were many kinds of projects. We were involved in team projects in which a number of us from the, like the lamp dimmer and other things that we're working on, there were a number of us doing that kind of work.
Yeah.
I had my own separate projects which came in from the rest of the General Electric Company, the consulting projects, which I did consulting work on to help set up the systems like the Polaris fire control and guidance system. And it was a totally varied environment. Sometimes there would be teams and sometimes an individual. I was a sort of an individual worker. I had myself and another engineer and a technician assigned to me for quite a few years before I retired.
Well, it must have been exciting to go to work every day, because every day was a new challenge, a problem and something to solve.
Every day was a different day, and those were the days of General Electric Company when we served the General Electric Company as General Engineering Laboratory. We were consulting with people from the appliance departments and from industrial departments on a daily basis, by telephone usually.
Well, when we meet people like you, we just are fascinated because of the accomplishments and the things that you did. But you said something to me earlier that sort of made me smile. You said, we're just doing our jobs. You never thought of yourselves as pioneers or great minds or people that were solving world problems that affected the globe. You just said you just went to work and did your job. Is that how you felt about it?
I think so. I look back and I say we thought we were doing our job well, and it turns out that some of my co-workers were really truly outstanding creative engineers, and Leeanne Goldberg and Hal Chestnut.
And yourself included.
Thank you very much.
And some of the many Schenectady wizards that are being profiled here at the Edison Exploratorium. Harold, you worked with another individual named Roy Anderson, and Roy was a satellite communications specialist. What did you guys do? What did he do as a satellite communications specialist?
Roy was one of the innovators in the utilization of satellites for communications. And he was, of course, had a dish antenna up on the hill, up on Crawford Hill, and did some work. But his work really was involved with such things as setting up communications off a satellite at the beginning to airplanes down the South Pacific, Pan Am flight down the South Pacific. And I remember one episode we were up at the in Syracuse, however, at a GOSAM, General Electric Organization on Solid State Applications and Measurement.
And you remembered that.
Which we met.
That's a long name.
And lo and behold, there was we went out in the parking lot, and Roy pulled out an antenna which turned out to be an umbrella folded up to look like a satellite a dish antenna.
Yes.
And we talked to the pilot of a Pan Am flight down in the South Pacific. This was one of the early viewing, and from which now we have the GPS and all sorts of other satellite communications.
That's amazing. The GPS systems in our cars and are used worldwide now. That was an early portion of the development of a GPS system.
That's
well, what year was that? What time period was that? Well, just roughly, you know. Have an idea?
That's got to be at least over 30 years ago.
Over 30, Roy Anderson. Well, that's amazing. And you mentioned Crawford Hill. Crawford Hill, I'm aware that that's where our mobile radio district towers are. So apparently Crawford Hill is a good high elevation area that lended to the purpose of the satellite communication development in those days.
And we had a large directable antenna up there that Roy used for satellite communication and moon bounce experiments and other kinds of experiments.
Well,
with our,
that's an exotic word, moon bounce experiments. What would that be? What would a moon bounce experiment, what does that mean?
well, if you want to communicate with some place in the world where you can't get direct RF path, you can bounce the signal off the moon and receive it someplace else on Earth. And it takes a few seconds for that to occur. And you can, we used to, our communication systems used moon bounce. It turns out it's very interesting because you talk and then you wait for a few seconds till somebody hears what you say and then answers you back. And it's...
So does that have something to do with like the recent radio repeaters and off of satellites, communication systems off of satellites as we've known them recently?
They, somewhat different subject, but they have grown.
Yeah. Okay.
They've all grown through the use of satellites, and we don't use moon bounce because now we use satellites instead for the communication.
Yes. Well, very interesting. Well, Harold, thanks again.
Thank you.
Harold Gauper, thank you very much for being with us.
Good again. Thank you.
Okay.